Hello grade 12s and mathematics phonetics. Right, so folks, we are upon the year 2026. Happy New Year to you all, and I hope most of you who were my students last year will have made your progress into your chosen careers. May you flourish there as well. Otherwise, for a new matriculant and those who are willing to have a look at this again, here's some work. There is a video that I introduce a student into sequences and series in a more in-depth analysis type of a thing, and I do believe it helps or aids students to then try to figure out things rather than to just know this is the formula, this is how I use it. Sometimes, how did we come to that formula? What led to that formula? So all of those things become very useful as one progresses in life. Right, folks, we are going to just revise our sequences and series, question by question, type for type, and all that. Right, so this is the topic for today. It's sequences and series. And if you want this document, I will have it in the description for those who wish to have it, because it has lots of questions for one to prepare very well for Term 1 exams. Now, the main topic for today or for this video is going to be the quadratic pattern. So this is a revision from grade 11, right? So it carries on to grade 12. Now, what is the definition of a quadratic number pattern? So this is a pattern or a sequence where there is a constant second difference. Okay, we say it's common or constant. This is for the equal part. Sometimes depends on who compiles the document. We say it's common or constant. Right. So these words can be used to describe the state of the second difference. Now this is suggesting that the first differences form an arithmetic sequence. This is the sequence which has already been taught in grade 10. Now folks, here's what is important as well is the general term for any term in a quadratic sequence. So we can see that this is an squared plus bn plus c. This is similar to our quadratic equation f of x equals ax squared plus bx plus c. So this means all the properties of a quadratic function or equation may be used here. But remember, there is a little bit of caution in how we use those. Here, there's some heavy restrictions. We need to know importantly that n is an element of natural numbers. Now, what are natural numbers? This is 1, 2, 3, 4, and it goes to positive infinity. So in essence, these are what we would call positive integers, right? So 0 is not a part of this because it's not necessarily positive. 0 is in between. So these are essentially positive integers. So that's just a restriction on the domain of this function. And remember, certain things are not going to work as it would for a quadratic equation, but some aspects may be applied, but with caution. Please remember that, guys. Now, what is important? How do we find our coefficients? Well, our coefficients can be found easily by just, dealing with issues nicely and say, look, term 1, remember this is a position. So term 1, when we substitute into the original, we end up with this guy. right? So this means in general, the very first term of a quadratic sequence can be expressed by a plus b plus c. Then if we go on, we will notice that the second term, when we plug a 2 where n is, we get a 4a plus 2b plus c. Now remember, I'm putting an asterisk to suggest that this needs to be known and understood because it may be needed even when you least expect it. Same when we put when we put n equals 3 into our general formula, we get that the third term in general is 9a plus 3b plus c. Okay? The fourth term and any other term, we just do that. So this means in general we can express any term in the quadratic pattern without really finding the actual value of that term. Okay guys, I'm cooking. I don't want to bend because it's easy to bend things, you know. So I can see starting to do so. Right, say staying alone is a problem. Anyway, I guess okay. Right. Now we can see that is the terms of the quadratic sequence, but I am putting a specific emphasis on the first term, right? Now we go on to the second one. If we look at the sequence of the first differences, the very first term is going to be 3a plus b. This is very important to remember because it takes us home most of the time. But remember, these are also very important, meaning the second term is going to be 5a plus b. Can you see the first term increases by 2a each time? The third term becomes 7a plus b and so forth. So this is to say, although 3a plus b is our usual place for safety, but we may find ourselves needing the others. So we need to be comfortable doing this. Now the last one here is the common second difference. As you can see, this remains the same. So essentially, that is what we need, folks. And now I will say to you, my students, pay attention to these important three. So this is how we usually work things out in a quadratic sequence when the question is very basic and standard. But when questions are tricky, the other terms that I've highlighted may be useful. Now, as I said, this is a quadratic pattern, so it means we may have a minimum value in the sequence. Because this is quadratic, we know that it can be limited at the turning points, but sometimes not exactly at the turning points, okay? But the concept of a minimum as well as a maximum should be entertained. Right, so how do we handle business? So we know that, like in any other quadratic equation, this gives us the x coordinate of the turning point. In this case, it gives us the term number or the position of that term. Okay, so this is very easy. Or for those who already know differential calculus, this can also be used where we differentiate with respect to n, or the so-called first derivative. Now this may come in term 2 for a new matriculant, but for those who are essentially, aware of this, this can be used. Right. The fact that it's going to come in term 2, it doesn't mean if you know you can use it, you can't use in term 1. Okay. Maths, guys, is not limited as people try to make it. It's not. As long as it is applicable, sensible, and it holds the signs true, it can be applied. Because here we want an open mind. We're not locking people into some box. Okay. Please don't forget that. Right. So folks, this is the quadratic pattern. I'm not going to go to the others. We will next look at the arithmetic and then the geometric. And with the geometric, we've got the concept of sum to infinity. So you already know the arithmetic from grade, you already know this from grade 10. So there's not a lot to talk about it, but we're going to leave it at that for now. Right, now let's get to questions. Alright guys, so here are some questions. Of course, I said this document is going to be available in the description for those who want to have it. Otherwise, go and check from Stanmore Physics. You will also find this document. Now, we'll look at our first question. I'm going to rush this because I want to watch the CAF final, okay, AFCON final. Right, so this came from DBE, May, June, (2019). Okay, again, this is the reference of the question, meaning one can go and download this paper and enjoy the rest of the questions in that paper as well. So let's see, 1.1. We are told that there are 4 terms of this quadratic pattern, 15, 29, 41, and 51. And we need to write down the value of the 5th term. Now, once the question says write down, it means answer only, guys. Please don't be doing too much. There is a chance for rough work on a different page or within this page or your answer sheet, as long as you split it clearly. It's very important. But if you want to show things, make sure they are correct, because you may be in trouble if ever everything is not making sense. Right, so we know that our quadratic pattern is 15, 29, 41, 51, and it continues. And we know that there is a sequence of first differences here. So 29 minus 15 is 14, right? And then we do that. 41 minus 29 is 12. We go on, 51, minus 41 is 10. And by the way, this is a sequence. So it continues. And we know we're going to have the second differences. So 12 minus 14 is minus 2. 10 minus 12 is minus 2. And we can see that this is constant. Since we were told that this is a quadratic pattern, we don't even need to expand more so that we can see that indeed the second difference is constant. We just have to believe it. Okay, even if there was just one of each, or maybe 1 second difference, since we are told clearly that this is a quadratic, we don't need to prove it. Now, folks, we want the next term here. What would be the next term? Now, if you look at this, guys, of course, you can do whatever you are taught at school, but there are some shorthand techniques which help to get the right answer. Now, all we know is that to get the next term, if we add these ones up, they will give us the next term. So minus 2 plus 10, that's 8. 8 plus 51, that's 59. Okay, so this is our term that we're looking for. So now we're going to write the answer. So therefore, T sub 5 is 59. Remember, always write the answer. But usually, an answer only here is accepted. So another student may decide, okay, that there would be another 2 here. Then say 10 minus 2 gives us 8. Or we can say minus 2 plus 10 is 8. And then we say 8 plus 51 would still give us 59. So However one looks at this, please get it right. Okay, so let's get to 1.2. 1.2 says determine an expression for the nth term of the pattern. I don't know why STEM Physics always does this. This thing needs to stop. I mean, come on, man. Why make these papers available and then you have this sitting over the text? It's crazy. Anyway, so we want to know it in the standard quadratic format. So as I said, folks, do you remember? We said, look at this, because in general, these take us home, okay? So we know that 2a is going to be minus 2. Therefore, a is minus 1. So this implies we know that the very first term of the first differences is 3a. A is minus 1 plus b should be equal to 14. Therefore, our b is 17. This also implies that we look at the very first term now. We know that a, which is minus 1, plus b, which is 17, plus c should give us the very first term, which is 15. Therefore, c would be, this is 16 transpose, we get minus 1. So from here we can make a conclusion. T sub n is minus n squared. Remember, we don't write minus 1n plus 17n minus 1. So this is our answer, guys. So it's done. So usually we get a mark for this, for that, and for that, and for writing the equation properly. But I would like to highlight for a student, please guys, check the formula of the general term, or should I say check the general term for correctness, please. Meaning we can check any other term that we choose. For example, let's just choose term number 3. Will we get 41? So we've got minus into 3 squared plus 17 into 3 minus 1. Indeed, we get 41. So I always choose non-contiguous terms. Let's look at term 5. Will we get that 51? Indeed, we get 59. Sorry, not 51. So I know for a fact that as I'm presenting this answer, I am 100% correct. So with maths, guys, there's lots of areas where you know for sure what you're getting. Although some questions may not, but at the same time, be meticulous, because usually those questions involve some formula, some form of substitution, and the answer. At some point, you may not be sure about the answer, but making sure that the formula is correct, the substitution is correct, then the answer should be correct. Of course, provided the operations were correct. All right, guys, so that is essentially how we deal with that question. So let's get to 1.3. 1.3 tells us to find term number 27. So we need to write the general formula. T sub n equals minus n squared plus 17n minus 1. So this implies that T sub 27 is going to be minus into 27 squared plus 17 into 27 minus 1. Now let's put it on the calculator quickly. So minus into 27 squared plus 17 into 27 minus 1. We get minus 271. Now remember, there's no way one can check this, right? So the most important is to ensure that this formula is written correctly and that the substitutions are correct and that the operation is good. So meaning calculator must be on point here. Okay, so guys, as you can see, easy 2 marks, nothing out of the ordinary here. Now folks, I would like to add some higher grade questions or level 3 or level 4 type of questions, because at the end of the day, this is a very fertile ground for such questions. So now how about we add a 1.4? So you will see that this year with the videos we do, we're going to create questions so that you guys get to understand better. It's not about just solving, a particular question and then moving on. Chances are you may not see that question again. So we might as well, be on the lookout for trouble. Now, what if someone says, what is the value of the maximum term of this sequence? Sometimes it can be a pattern, okay? This is a question. What is the value of the maximum term of the sequence? Right. So how does a student respond to these questions? As I said, these are higher grade questions, folks. Students need to be able to answer these questions without flinching. Right, so there's 2 ways we can solve this. Obviously, once we hear the word maximum, we know that it's the term pretty much at the turning point or close by, because remember, there's a catch with sequences and series. It's not essentially the domain being the real numbers. This time we're talking about positive integers. Now the first way to go about it is to use the usual. We know that we need the position first. So we know that, first of all, we know that t sub n is minus n squared plus 17n minus 1. Now we know that n here is going to be minus b over 2a. Please be clear, guys, what formulas you are using. So this implies that n is going to be minus into 17 all divided by 2 into minus 1. This implies that n is equal to 17 over 2. Now, you see, we have a problem. Do we ever have n being a decimal? No. So we need to do something. So n must either be, now remember this is 8,5. So we can either round down or we can round up, right? But be careful, check these 2 as well if indeed they will satisfy this, because the reason for doing this is because n is an element of natural numbers. So we can't have n as a decimal. N is not a real number. So it is very important to be sure. The reason I'm doing this is because I know that there is symmetry. So if n is sort of like 17,5, that is between 8 and 9. So logically I know 8 and 9 should be equidistant from that turning point. So this means the turning point physically does not exist, but the term before and after that turning point is what may be the maximum. But we're going to check this, because if we don't check, we will run into problems. We can say, therefore, T8, is minus into 8 squared plus 17 into 8 minus 1. let's see what is that. So we've got minus into 8 squared plus 17 into 8 minus 1, and we get 71. Okay, let's see. T9 is going to be minus into 9 squared plus 17 into 9 minus 1. T9 is... So these questions, guys, I don't just answer carelessly, please. It's 71 as well. So can you see? It's only because I know the turning point was kind of a mean between the two. If you understand what the arithmetic mean means or things like that. So it's 71. Can you see? Basically, term number 8 and term number 9 are the same. So now we answer the question. Therefore, there's so many therefores here, I could not avoid them. We can say, therefore, the maximum no, what is that? The maximum term is equal to 71. It doesn't matter that there's two of them, but the question was on the value of that maximum. So this is very important to realize. So can you see we used our n equals to minus b over 2a, and then we substituted the n value into the original, because from here we go back to the original to find the actual value. Okay, so please know how to do this, but remember the catch. Remember the catch. So when you get a decimal, you have to deal with it accordingly, and checking is not a problem. So this question was not too easy, although, well, you can say level 3, but as you can see, I would put it at a 4, because to know what to do with the n and also to be careful around it until getting the final answer is very important. Okay, so where would we get the mark here? Remember, in maths we don't get a mark for the formula, but the substitution, this value or the other, it doesn't matter, and then the final answer. So I would give this one 3 marks, although it's technical in nature, because you know what, guys, this is dangerous. Another question that could be asked, just for interest's sakes, because now that we know what happened, we can decide to scrap this question and just ask this question and say, which term or terms of the sequence is or are, or let's just say of the sequence has the maximum value. Right. So which term or terms of the sequence has a maximum value? The answer to that is term number 8 and term number 9. So can you see the catch is on this one? Is it one term? Is it two terms? So there are many ways in which we can ask questions that can actually cause a bit of pain for a student. All right, so this is one way of solving the problem. How about the second way? Remember, guys, this is learning in progress. So how about we choose to complete the square? So we know that t sub n was minus n squared plus 17n minus 1. So this also implies that t sub n equals, we factor out the negative, so we get n squared minus 17n plus 1, right? So this implies t sub n is minus into. Now what do? We take that under the square, we take the sign between them, we have the coefficient of n, and of course we put it under the square. This is what is the case, so we add the 1, we immediately subtract half of what was the coefficient of n immediately, because in a maths we can just add 0. Adding 0 is as good as adding nothing. Okay, so nothing has changed. So this is a technique of just, adding 0 technically, but then grouping, the n squared with the other one so that we have a perfect trinomial. Now we redistribute our negative, so we get minus into n minus 17 over 2 all squared plus, now we sort this out, so we're going to have 1 minus 17 over 2 all squared. So the answer that we get is actually a negative here. Okay, but negative, right, it's going to be negative. Maybe I rushed. This would have been negative, but when we redistribute this, it becomes positive 285 over 4. I kind of jumped, but anyway, it's done. Now, what would you do? Of course, a careless student would then say this is the maximum value. But now, you are not at liberty to do that, okay? You are not at liberty to do that because this would give us a term number that is not a natural number. So because of that, what are we going to have to do? You take this down. You will say n must be equal to, remember, it's going to be 17 over 2, right? And you go on and say, therefore, n is either 8 or n is a 9. Again, understanding that this is a quadratic. Now, what we can do, we can actually take the n value and substitute here, or take the n value and substitute into the original. It's not a problem. Or we do that, substitute in there, or we take it into the original. Right, so that would work because we would see that Tn here is 71. Therefore, we answer the question, the maximum term is equal to 71. So can you see two different techniques where you need to be careful? As I said, if this was a natural number or a whole number, then we would accept that this is the maximum value. But because this is not a whole number, we cannot accept the maximum there. We need to deal with n as well as the rest of the business. Okay, guys, please, 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 please. This is very important. So I hope you can see where the problems can arise if we are not careful. Okay, so that is essentially that question. And I think we are doing fine. The match has started, so I'm falling behind and I don't like it. I don't like it. All right, guys, so that's it for that question. Let's take the second question and maybe stop there. Now, the challenge for a student is to draw the graph of that sequence. Please, this is something that you need to know how to do. Draw the graph of Tn. Do this, and perhaps, I don't know, those of you guys who are in the group, the WhatsApp group, please take a snapshot of your drawing and show me. I would gladly want to see what's cooking. If you don't have my WhatsApp number, just go to the channel's description. You will see there's my WhatsApp number together with my email. However you choose to show me your drawing, but I would love to see your drawing so that we can sort it out if there's something wrong. All right, so let's do question 2. We're just gonna do 2 questions for now to avoid making the video too long. So question 2 is taken from IEB November 2019. Again, this reference is very important, meaning you can go and find that question paper and play with the rest of those questions. All right, so let's see. 2.1 says, anyway, we are told that the table below shows the number of passengers that were on a bus after every stop. Okay, now it's either these guys are going off or they are going on, right? These questions can be asked like a very simple 2-mark question. Are the passengers getting onto the bus or they are getting off the bus? Now we can see that on the first stop we've got 2, on the second we've got 20, on the third we've got 34, on the fourth we've got 44. So obviously we can see that the number is increasing. So people are getting on the bus than getting off the bus. Right, so the number of passengers on the bus after nth bus stops can be given by, and we are told here that this is the general quadratic term as we know it, where a and b are elements of real numbers and essentially they are constants. Right, now the first question says we need to write down, can you know what that means? Answer only. Write down the number of passengers on the bus after the 5th stop. As we know that this is a pattern, so if we figured it out, we are going somewhere. Now the question is, what pattern is this? Now, it's easy to tell because we are dealing with a quadratic pattern here in this video. So this is what it means. But if you didn't know, you investigate, okay? So we know that the sequence of these passengers is quadratic, of course. Now, I'm just giving it away. So this was 20, this was 34, this was 44, and of course, they kept on hopping on. So we're going to work it out. So fine, check. 20 minus 2 is 18. 20 minus 34 minus 20 is 14. 44 minus 34, so it's 10, right? Right. So this forms a sequence. And we can see that this is different, so we go on until we find a common difference. 14 minus 18 is minus 4. Again, 10 minus 14 is minus 4. Now we can clearly see that this is quadratic. Of course, I knew now because we're dealing with a quadratic, so it should be easy to figure that out. But in the exam, it's not so easy to see. Wow, Senegalese are on fire. They almost scored. These guys are going to win this thing, hey? Anyway, let's move on, folks. So the question was, we need to write this 5th stop number of passengers. 1, 2, 3, 4. So as I showed you guys, we just do our thing, or however you were taught to do this. So if I add this minus 4 plus 10, I get 6. Then 6 plus 44 is 50. So I can safely say, therefore, T5 is equal to 50. Or we can say, therefore, there were 50 passengers on the 5th stop. At this stage, this is acceptable. We can leave it here. Of course, it's just 1 mark, guys. But there's nothing wrong in showing how we got it and how we move forward with it. Okay, 2.2. 2.2 says, determine the values of A, B, and C. So this is easy. We start at the very bottom. 2a is minus 4. Therefore, a is minus 2. So this implies that 3 into a plus b should be 18. Therefore, b is, so this is minus 6. We bring it on, we get 24, right? So this implies that a, which is minus 2, plus 24, which is b, plus c, should give us 2. Therefore, c is, now this is 22. We bring it, we get minus 20. Right, so that is it, because nobody said find the general formula. At this point, this is the answer. So we get our mark for each, and that's it. 3 marks. Nah, I don't know why 4 marks are being given here. That's chicanar. That's chicanar. Okay, please. Very easy. So we're using our standard technique. Can you see, guys? We focused on these dudes. As I said, pay attention to these. But there are instances where we may not use those. Okay. And if you want, go and check a video on sequences and series that I have done last year already. Please take it from the beginning until the end. Don't be in a hurry to get to the answer. Rather go through it step by step, where I show you how to use your head as well as the knowledge that is established to kind of understand this topic better. So this is just a supplementation to that video. So this video is too summarized, so please don't sit here and think you are fine. 2.3 says, if it is given that Tn is like that, determine the maximum number of passengers on the bus. Can you see? We need to find the maximum number of passengers in this bus. So meaning, when will it be full so that there's no more passengers it can take? Right, so this is very important. Now we write our general formula. T sub n is equal to minus 2n squared plus 24n minus 20. Please check that this formula represents that sequence, okay? At this point, I'm going to trust that it does. Now to find the maximum, now we need to check. Now I would like to use, you can use the usual technique as you can see. Please do so if you can. But I'm going to use the completion of the square just to avoid wasting time. T sub n is equal to minus 2. We factor this out. We get n squared minus 24 divided by 2 is 12n plus. Minus 20 divided by minus 2, that's plus 10. Okay, so this implies that T sub n equals minus 2 into, you know what to do here, it's n minus half of this is 6. Then we square this thing, we add 10, and we subtract that half squared. Then we move on, T sub n equals minus 2 into n minus 6 all squared minus, so this is 36, so 10 minus 36 is minus 26. Right, and then we redistribute this, so we can say therefore T sub n is minus 2 into n minus 6 all squared plus, this times 2 is going to be 52. Now we look again. Do we see a whole number here? Yes. So what is our maximum? This is our maximum. Right, so we can say from here, therefore, maximum number of terms, the maximum number of passengers is 52. Nice and easy. Of course, use the formula to do this, and those who can use differential calculus, they can do that. But I'm just trying to show you these things simplify your life if you master them. So I would say to you guys, please master the technique of completing the square. Please. Master the technique of completing the square. It will take you far. But for the sake of not trying to make the video too long, as I said, students can use, you can still use n is equal to minus b over 2a, and then substitute into t of minus b over 2a, right, to find the term, right? It should be the same. Or, even better, there's a formula that goes straight. We know that t sub n here is going to be 4ac minus b squared over 4a. But be very careful here. It will be dangerous if n here is not a natural number or a whole number. For this to apply, this guy must be a whole number. So before you can jump in here, please run a check that this is the case and the answer is a whole number. Then you can just go straight to that formula. But don't go straight to that formula without knowing what is going on in there. But even the quality of the answer, you will see if the sequence is a sequence of whole numbers, the moment when you use this formula, get a decimal, you know that there's something wrong there. It means the term position of that value is not a natural number. Okay, guys, I cannot overly emphasize this. Please don't miss out on this. I beg you. So now writing this like that is very important. Remember, you are told in your curriculum that essentially completing the square is not examinable. They say so, but the truth be told, it is user-friendly. So anyway, we just take it as writing our formula in the vertex form, and then we can take 2 marks for knowing that the answer is like that. So this could be a 3-mark question, or at least it could be marked like that, or any other way that you may choose. Right, now let's get to the next question. So 2.4. 2.4 says explain why the formula calculated in question 2.3 does not work after the 11th stop. So what happens after the 11th stop? As you can see, this is a higher grade question, and essentially you cannot answer without knowing what's going on. Now students, I don't know what you would want to say there, but here's how you go and look at this. You first find out what is the value of T11. That's very important. So we can say T sub 11 is going to be minus into 11 squared. Sorry, this is minus 2 into 11 squared plus 24 into 11 minus 20. It helps to find out because we want to know, is it an x-intercept or is it something else? So this is good. Or squared plus 24 into 11 minus 20. So we see that this is 2. So it is the mirror image of the first term. So it's not the turning point per se, but a mirror image of what we have. Okay, good. In this case, guys, I would like to just draw the sketch for you to see what's going on. So this quadratic is doing stuff like this. Obviously, it starts at a 2, so we know that this is what we have. Right, this is what we have, because remember we start from term 1. So this is 2. Now term 11 is coming up the same. As I told you, we can't have any term before term 1. It does not exist. But now this one may still continue. But if you look at this one, it continues into the negative, because already we can see that the x-intercept here is going to be some 11 comma some change. It's not going to be a whole number. So this is not an x-intercept. So why does this not work? It means the x-intercept does not exist because it's not a whole number, and this means the next term is going to be negative. Let's check it out. What is T12 going to look like? So again, guys, these questions demand a lot of carefulness and a clear understanding. Can you see it's minus 20? So the next term here is negative. Now, if the next term is negative, what does that mean? This means that maybe we can even do it and say, look, also term 12 is minus 2 into 12 squared plus 24 into 11 minus 20. We will see that term 12 is, wow, I took it out now. I thought it was minus 20, right? I think so. So minus 2 into 12 squared plus 24 into 12 minus 20. We got minus 20. So we can see okay. Is it possible for us to have a negative number of passengers? That's not practical, because this is n, this is t sub n. So we know that, okay, first of all, the next term after term 11 is negative. And since we cannot have a negative number of passengers, we'll just say, therefore, this does not work because the next term from term 11 is negative. We can say, since there is practically no negative number of items, or should we say there's no negative number of passengers, since there is practically no negative number of passengers, or perhaps we can say, therefore, there is no negative number of passengers possible. Perhaps we can just make this a conclusion. Right. So therefore, there is practically no negative number of passengers possible. I think that is the best explanation I can give. And okay, we see what we see. So again, can you see, guys, how we go through this is very important. To score these 3 marks, I think it's important to get T11 to make sure it's not an x-intercept or anything, and that it's also not a negative. And to find this is very important. And then to explain what is cooking is essentially the seal to this. Okay, so I hope you understand, guys, that to answer these questions is not too difficult, but it is a technical situation. Now let me hoy my last question, as always. Now we may be asked a question. So this is 2.5. This one says, for which values of P must be added to the sequence so that all terms are negative. Right. So for which values of small letter p must be added to the sequence so that all terms are negative? Right, so we are good here. Okay guys, so we realized that, okay, the maximum term here was term number 6, isn't it? So we know that term number 6, because the turning point doesn't exist, so we know that there we had term 6, right? And of course, there is going to be a mirror image because this is a quadratic. But is it possible? Okay, let's see. I'm trying to think now. But there should be something here. But is it? Is it going to be practical? Let's see. From term 1 to 2, that's 5. From 11 minus 5, that's 6. Okay? So it means the mirror image here does not exist. Is a position that would not work. So this one does not exist. So as much as it is a quadratic, this is the only maximum that is valid. So can you see? So now, folks, the question is now, how many things must we add? Remember, we saw that this was 52. So obviously, we just need to take this down by more than 52. So we can clearly see here that the answer, guys. So this is just a 2-mark question, essentially. So we can say that therefore P must be less than minus 52. Remember, P must take this down. So if we add a value more than 52, all these terms are going to be negative. Remember, the turning point, we don't care about it. It does not exist for this. So again, easy 2 marks. Nice and easy. Now, here's another smart technique a student can think about. This is another way of answering the same question. As I said, learn how to complete the square. So we can say Tn plus P must be less than 0. So this implies that T sub n is minus 2n squared plus 24n minus 20 plus P must be less than 0. And then we decide we're going to complete the square here. If we complete the square, we factor out the negative because we want to solve. So we get n squared minus 12n plus 10 minus p over 2. Remember, when we force the 2 out, this is what we're going to get. This must be less than 0. So we get minus 2 into, again, we know what to do here, all squared plus 10 remember these are constants, minus p over 2, and then we immediately subtract 6 squared. Again, this must be less than 0. So this implies that we've got minus 2 into n minus 6 all squared. Then we sort this out. This is 36 minus 10. It gives us minus 26 minus p over 2. Okay, we leave this one alone. Less than 0. Then we redistribute our 2. So we get minus 2 into n minus 6 all squared. This one we will get 52 plus p less than 0. Now we can see, guys, that this is a perfect square, right? So this means this whole shenanigan is negative, right? Because a perfect square will always be positive or 0. And so if we multiply this by negative, it will be negative or 0, at least. But yeah, that's what we can say. Now, this means for this whole shenanigan to be less than 0, this guy must be less than 0, isn't it? So this implies that 52 plus p must be less than 0 for that thing to be less than 0. So if we transpose, we will see that p must be less than 52. Nice and easy. So folks, mathematics is a beautiful subject if only you understand the basics you are taught, and you can use them to your advantage, provided you know how to do the maths correctly. Anyway, folks, this is great. So we need to move on to the next few questions. Please practice as many questions as you can find. There is a whole lot of nice higher grade questions on this, including simultaneous equations. Otherwise, I would like to stop here and leave a thumbs up and share the video to your friends, and perhaps consider subscribing to the channel so that every time I drop these very important little bits and pieces that that can make the beast out of you, then you don't get to miss out from these. And on top of that, you get to access every single video there is here, and you may have access to me as well. But I do answer questions even if you're not subscribed, so don't fear that if you're not subscribed, you're not going to be answered. I prioritize every person who interacts because it shows interest. Anyway, I will see you guys again next time. Goodbye for now. Keep practicing.